Hello, I'm Brent Farris from the BMS Studios, and today I want to go over object inheritance inside of Unity. I told some people about object inheritance and deriving from monobehavior and all that stuff, and people were like, what, you can do that? Because they're trained to, in most game engines, you're using their proprietary scripting language. JavaScript is it's a form of JavaScript for Unity that they modded really to work with their engine. Just like Farris is a scripting language for the Skyrim editor, or Unreal Script was for Unreal 3, and Lua is used in other engines. So we're kind of trained of like, oh, we have no idea what these codes can do. Now I want to stress the point that C# inside of Unity is definitely the full implementation, if not a partial, mostly. There's hardly anything they're missing inside of inside of Unity, and it's Mono 2.0. It's their you can use either the full or their subset. You can find that actually if you go to the player settings. You can go down to here. It says API compatibility level, and you can say .NET 2.0 or .NET 2.0 subset. It's usually set to subset because that's Unity's flavor. Anyways. It's full C# 2.0. You can do anything that you imagine that you could do with C# 2.0. So, let's begin the object inheritance, shall we? I'm going to create a C# script and call it enemy. And then I'm going to create a second script and call it evil sphere. So I'm going to open these two guys up inside of Mono. Hopefully it opens up quick. Sweet. So, enemy sphere, I'm going to actually remove mono behavior from it, and you'll see that you cannot drag a non-mono behavior script onto an object. It will tell you it does not derive from mono behavior, so I'm not going to do that. So what can we do? Well, we have an enemy who derives from mono behavior. Well, we can derive the enemy sphere from enemy because, well, it's an enemy, right? It's an evil sphere. Now if we try to drag the evil sphere onto the sphere, it works fine, and if we drag the enemy onto the cube, it works fine. You can see that they are both on the objects. So, number 2 question, whenever I say you can inherit inside of Unity, the question is, what about built-in functions? We have these private void start, and this update, and this late update, and this fix update, and this on render, and on disable, and all these other things built into Unity. Well, it works just like you would imagine in C#. Rather than saying private void start, you're going to say protected virtual void start. And we can do that the same thing to update. So now when we go to the evil sphere, we're going to, instead of saying private void start, we're going to say private override or protected override start. And we're going to do the same thing for update. Now instead of start, I'm going to do awake for this example, so because it comes before start. So let's stick awake here. Now you'll see that whenever I add a public variable, so public float speed is equal to, let's say 5.325 is fine, f. So our speed is 5.25, and that's public float. Our evil sphere is automatically going to inherit that and show it in the inspector as you would imagine. And it's totally independent, of course, so I can definitely increase the speed of the sphere versus the cube. Now let's just do something, shall we, with the, we want them both to move up by this amount. We don't want to set that in each individual class. So let's do a transform.position plus equals vector3, vector3.up multiplied by the speed multiplied by the time.delta time. And if I haven't explained time.delta time before to you, what time.delta time does, it makes it CPU independent. So you have a CPU that runs slower, say 1 gigahertz. You have another CPU that runs much faster, say 3 gigahertz. Those two are going to hit updates at a vastly different interval. So on the very fast computer, it's going to hit update, let's just be arbitrary, 1 billion times, versus the one that is much slower hits it 1 million times. So you can see how much slower it is. That is not actual numbers, by the way. But this is a modulus in order to get them equivalent on both machines, because it's the time between 2 frames, and time is a constant between any machine. So that's what that is. That's not the main part of this. That's about that on that. So Now that we have added this, you're going to see that we need to make it happen in the base class because we have indeed overridden the function. So what we want to do is call the child class. We want to call base.update, and that's all we have to do. And we can do the same thing for awake. So base.awake. And that is, of course, if we want to call what's in the primary class. So if we didn't call this update, this base.update, and hit play, you're going to see it's not going to do anything. However, when we call the base.update, it's obviously going to move by its speed, which is faster, if you remember, than the cube, because I changed it inside of the inspector. So why did I want to make this awake? Well, let's do a protected, I can't spell, virtual void start. And also, let's create a debug, just to stress the point of this. We're going to log out, I'm an object, an enemy. Let's just say enemy object. And inside of our evil sphere, we're going to call that, and we're also going to call debug.log, I'm also an evil sphere object. So now if we hit play, we're going to see that it's going to do 3 logs. We're going to do this log for the cube, which is an enemy, saying I'm an enemy. We're going to do a log for the sphere, which says I'm an enemy. And then we're going to do the log for the child of the sphere, which is the enemy, which is the evil sphere, saying I'm also a sphere object. So you can see that it is definitely overriding and it's not just overriding and calling the base class, but we're doing extra functionality. So inside of the enemy, we're going to have a protected virtual void start, and this is going to be a pure virtual function because we're not going to add anything inside of the body of it. And that means in our child class, we don't even need to call the base because it's not doing anything unless we expect to do something later on down the line. So in the start, I want to show one of the awesome things you can do within Unity now. Let's say enemy array E, let's just call it E, is equal to GameObject.find objects of type of enemy, and we're going to set that as an enemy array. Now, obviously, we can iterate through, and now we have, well, let's just show it. Let's say debug.log e.length. So even though we're only getting the base class enemy, by getting the base class, we are getting all of the children. You can see there's 2 there, one for the cube and one for the sphere. And to further stress this point, let's create a public function and call it callout. So let's say protected virtual void callout. And inside of this callout, I'm going to say debug.log enemy here calling out. And inside of the evil sphere, we're actually going to override that function and not call the base functionality. Not protected, public. Did I make the other one public? Public override void callout. Let me check to make sure I made the other one public. Nope. It needs to be public. So, and this one we're going to debug.log evil sphere here calling out. And what we're going to do is, rather than debug logging the e.length, we're going to do for each enemy e, let's just call it e2 in e2.callout. Now when we run it, you're going to see enemy here calling out and evil sphere here calling out. So you can see that even though we got a base generic, I call it a base generic because I can't think of the word for it right now. It's not generic because generic is anything. But I'll just call it base generic or enemy generic. We're getting all of the things of type enemy. Now evil sphere is type enemy because it's derived from it. So it's also getting grabbed in there. However, when I call the overridden callout, it's going to call the proper callout even though this is of type enemy. So I hope you enjoyed this, and I hope it helped you out. I hope to see some awesome objects that you make in Unity. So post them up. Let me know what you got. Feel free to subscribe if you like what I do here. Feel free to put response videos of the awesome stuff you make. I always like to see those. So until next time, have a good one.